Greetings, I am Maleficious, and I'm back with more of Shenzhen IO. And, well, last time, once again, I went over solutions for previous series episodes, and again, I got stuck on those puzzles I tried. But I do have solutions for those now, and I've also got a mug of tea from Celestial Seasonings again. This time I've got Caramel Apple Dream, which is one of their holiday flavors. And it's pretty good. It's fairly apple tasting. Well, okay, there's the hints of caramel. But yeah, they put these flavors out starting in November. There's Caramel Apple Dream, there's Candy Cane Lane, which I had previously, that's a decaf green tea. There's Sweet Harvest Pumpkin, that's a black tea, that's pretty good. There's one Sugar Cookie Sleigh Ride. It's another herbal tea, but I'm not that fond of that one in particular. There's also a gingerbread flavor I haven't tried yet, I think. And apparently there's also a cranberry flavor I haven't tried, but I don't think I've seen that one in stores, so I guess I'll have to look for it and give it a try. But yeah, on to the solutions. So, yeah, I got really stuck on the smart grid control router. And I ended up, I spent like several, maybe up to 5 hours trying to work on this thing, coming up with a solution. And, well, it's kind of ingenious in its simplicity. I tried a lot of things. I tried utilizing the RAM chips, but I just couldn't get that to fit in. But, well, here, let me show you what I've got. Alright, so I've managed to condense this down to, well, yeah, I've managed to condense this down to 3 MC6000s and 2 MC4000X controllers, and of course you have to use the security chip. But yeah, I've wired this up so all the imports go into this one microcontroller, and it's set up to sleep until anything comes in. I move that whatever comes in into the accumulator so I can save it, and then I move it out the X1 port into this microcontroller, which does the same thing pretty much, but I also move it out into this controller. Because each of the 3 large controllers is associated with one of the outputs. This one with higher out, this one with meter out, and this one with lower out. And for the most part, they do exactly the same thing. So yeah, I've set them up to sleep until something comes in, then I move that into the DAT. Now I test if it's greater than 100, but I may need to change that. And I'll explain that in a bit, but we'll just go through. If it is greater than 100, then we have to test if it corresponds to the output. So in this case, for this one, if it's greater than the value in the chip, secure chip, this one if it's equal to the value in the chip, and this one if it's less than the value in the chip. So if it's not, then I jump back to the start and wait for the next data value. But if it is the right value, then I set it to sleep until the next value comes in, because the packet is in the right place and we need to start reading it in. So once another value comes in, I move that into the accumulator, because again, the first value to come in is the address. Yeah, the ID number of the destination, and indicates how the packet should be handled. And then the second number is the remaining length of the packet. So, after that, I move the DAT value out and the accumulator value out, and that's the first 2 numbers of the packet. And then I start a loop. I set it to sleep until it receives another value from the XBus port. And then test if the accumulator is greater than 0, which is, it should be if it's the length of the remaining packet. And so then, yeah, I test greater than 0, then I move. This may not work, well, no, I think it works fine. Yeah. I think it'll work. Anyway, move X0 out, subtract 1, and jump back to the start of the loop, which I see a problem now, which may or may not work. But anyway. But yeah, that happens. And so it should go through an entire packet. But what happens if it... Because I'm sending it to all three at the same time. So what happens if, say, this first value goes into here? Well, again, let's say I didn't have this test greater than value. So the first number would check less than this. It's not. So I'd jump back up to here. I would get the 4 in. I'd move it into that. And it would test. I would test if it's less than the meter value. And 4 is, so it would be... It would go through, which would be a problem. But since the first value seems to always be a 3-digit number, if I test greater than 100, I should be able to... I can filter out the rest of the packet and ignore it in cases when it's not in the right place. At least I hope so. It seemed to work the last 2 times I tried it. So anyway, I'm just going to run through the simulation. It seems to be working so far. And while that's going, I'm going to have a bit more tea. Yeah, you know, that worked. And of course, I've obviously done this the wrong way because it looks like the most common production cost is 9 yuan. And I've used about more than twice as much power as most people and a lot more code. But hey, I came up with this on my own. Well, mostly. I did get the greater than 100 part from researching on Reddit. I didn't actually see any solutions, but I did see... I put in the control route... I searched control router on the Shenzhen IO subreddit. But yeah, that helped. I don't think I would have figured it out without that. And that opened more projects and a new mail from Wu Lili. This is just the tip of the iceberg. Mr. Sun is apparently pulling in a lot of resources and groups to create various subsystems for something. Nobody knows what it is other than that it's going to be very big and potentially very lucrative for the firms involved. We're on a path to further our good relationship with his group and eventually become trusted partners, so let's continue to do our best work here. Oh yeah, as an interesting note, apparently this packet routing... Apparently the internet actually works like this with IP addresses and routing protocols, right? Something along that line. Apparently it's a very similar system, so we may be setting up a private internet. Or maybe not. I mean, after all, it's supposed to be for smart grid, civic infrastructure. But yeah, then I also have a solution for the Pocket Oracle. And yeah, as usual, I was pronouncing this wrong. Apparently, the first part is pronounced more like Yi, so it's Yi Qing. Or at least that's what the IPA for Pinyin Mandarin says on Wikipedia. I don't know, it seems fairly trustworthy. Also, I may be pronouncing the J wrong in Zhang's name. Apparently, J is pronounced more like a ch sound. So, it would be Zhang Qi. And I popped the mic. And that's going to happen a lot. Oh well. Solution. So, I managed to figure a way to solve this one. So, I'm using an MC6000 here, and another MC6000 here, and 2 4000Xs, and yes, 2 DX300s, because those are necessary. Yeah. So anyway, this one handles the input from the Oracle chip. So I'm testing if P1 is greater than 0, if the button is being pressed. If it's not, I jump to end. I can move a 0 to the accumulator and sleep 1, because I'm using the accumulator to handle the timekeeping, in part. But yeah, if it's greater than 0, then I enter into the loop. I test if the accumulator is less than 6. If it's not, I jump to the end. Oh, okay, no, that means if it's 6 or more, I jump to the end. Which makes sense, because that means the pulse is completed. But yeah, because I start the count at 0, so 0, 1, 2, 3, 4, 5, that's equal to, that makes it 6, and so if it is less than 6, Then I move the value in the accumulator into this microcontroller that I'm using as a subcontroller. Then I add 1 to the accumulator value to tick up. And then I test if P0 is greater than 0. So I'm checking if the output from the oracle is a 100. If it is, I move value of 1 through x2. And if it's 0, I move 0 through x2. Then I set this to sleep for 1 time unit and jump back to the start of the loop. And so if... yeah, no, it can't quite fall through because of this jump, but yeah, it gets the end, I clear the accelerator sleep 1, accumulator and sleep 1. Now this subcontroller, I set it to sleep until it receives data from the X3 port. I move that into the accumulator, and then I test if it's greater than 2. And if it is greater than 2, that means it's a 3, 4, or a 5. So I then implement a subtract 3 command, and then I move the value of the accumulator out x1. So, now this microcontroller handles the packets that I'm going to send to the DX chips, kind of, or at least it'll convert the simple output into, well, it'll convert it into a value I can use with the DX200s. So, once I get data from here, I move that into the data registry, because that's the value that I'm going to be setting. And this is why I have the sub 3, because if I get past a 3, 4, or a 5, that's too large to actually use with digit set command for the accumulator. So I have to reduce it by 3. That way, a 3 turns into a 0, a 4 turns into a 1, and a 5 turns into a 2. But yeah, once I have that number, I wait until I get data packet from this microcontroller, and then I do a digit set command using, so again, I use the digit I set is determined by whatever value is in data registry, and the value is determined by whatever comes across the X3 registry. Then I test equal if that is 2, in which case I need to the packet is complete, I need to pass on. So if it is, I move the accumulator out x2 and I move a 0 into the accumulator, because I have to reset it, otherwise it doesn't change. And if it's not equal to that 2, I jump back to the start of the loop. And then finally, this microcontroller is kind of also a subcontroller. It sleeps until it receives a packet from this controller, and it moves the first packet into the accumulator so I can hold it for a while. And I set it to sleep again until it receives more data from here. Then I move that one up here, and then I move the stored one out here, because the stored one needs to go through here and change these values, and the second one goes out here. So, verification. So, advance. Then now we got button push, and Oracle is generating values, so I can cycle through 1, 2, and you can see it's adjusting the value in the accumulator. And so, yeah, 0, so it, and day was 2, so it moved here. Now it's holding the 11 here. So it goes through 1, 0, and then we've gone to 101, moved here, we got pushed out here, and then the 11 got moved through here. So yeah, we've got 1, 1, 0, 1, 0, 1. And it displays at the right time too. So I'll just run through the simulation and have some more tea. It seems to be turning out pretty well. And there we go. As usual, I have a higher production cost, I'm using a lot more power and more lines of code. 777 power usage. I guess I hit the jackpot. Terrible jokes. Okay. From David P. Solomon. Splendid. How wonderful that such a device was created right here in China where it all began. I'll probably even use this oracle myself as Zhao Mei and I approach our wedding day. From Chang Chi. Zhang Chi. Yangtze? No. Maybe? No, I don't think so. David is more Chinese than even a Chinese person. Chi. From David P. Solomon, thanks. And winking emoticon.